So we are going to look at integration by parts as one of the techniques we can use in mathematics when we are dealing with integration. So by the end of the lesson, you must be able to integrate different functions using this technique. Now, when we talk about integration by parts, is a technique that we can use to integrate products of two functions. So when we talk about functions, take an example. You are going to be finding things of this nature, whereby you have x sine x dx, and they need you to integrate. Now, when you look at this integral here, you need to now, when you look at it, you will notice that this integral has two functions that are in x. So you have this one is one of the functions, and this one is the second function. So here, your function, in case maybe I write it in terms of x, we have x, and another function I have is sine of x. So when we are using integration by parts, you must be able to identify the two functions that you have that you are going to be dealing with. You can as well look at this. When you look here at ln x, let me know through the chat, or you can type in the chat. What do you think the answer is? Or is it possible for you to integrate it quickly? Anyone who can integrate it for us quickly in the chat, if you can. Anyone? Okay. Now, you notice that it might not be easy for you to integrate this. But when you look at this function here, it has two functions. And one of the function of fx, I can call it ln x. Now, may I know through the chat, what do you think the second function is? Type in the chat. What do you think in case we are letting g of x, what will the g of x equal to as our second function? What do you think? Our g, okay. So one person said 1, another one said x. Now, when you put here x, it means that you are creating another, for you are creating your own thing, because when you look here at x ln x, so if you are, when you have these two functions, you must be in position to multiply them because they must be a product. So g of x, there is a 1. So there is a silent one here that we shall be considering. Okay, we can as well have such functions where you have maybe this is ln x out of root of x dx. Still, when you look at this one, it will have two functions. You can say that one of my functions is going to be ln of x, and then the second function of g of x is going to be 1 out of root of x. So when you are dealing with integration by parts, you must be able to identify the two functions, and then you go on to choose which one is easy for you to integrate and which one is easy for you to differentiate. So this is what we are going to do. Now, I want you to let me know through the chat whether now at least you can be able to identify a function. When they give you an integral, is everyone on the call now? Are you able to identify that for this particular one, this is my function and this is my function? I've given you one here. Can you tell me through the chat what is going to be what are the two functions? Type in the chat quickly. What are the two? Okay. Yes, good. I have another one here that I want you to look at, and you tell me, what do you think your functions are? I have that. Look for two functions that you can use. Look for the two functions you can use. Okay. Ahmed is saying 2x and exponential, 2x and e to power 2x. Okay. Yes. Now, looking at the answers that are coming, that is very true. So here, you can say one of your function is going to be 2x, and then the other function, which can be in g of x, will be e to x. Now, that is the first step for you to be able to approach this particular number. So whenever you meet such a number, then you need to be in position to go on and identify what is your first function and what is your second function. Okay, let me hope that step is very, very fine. So now we are going to look at how does this approach look like? How does the technique look like? So we are going to derive it. Now, initially, when you are looking at integration, I'm very sure all of you, all those on the call, you might have looked at what we call the product rule. Now, integration by parts originates from what we call the product rule. We know very well that whenever I have my function, take an example, I have my y is equal to u and v. For this one, if this is my function, it means that the product means multiplication of two things. So if I have two functions I'm multiplying, here one of my function is u, and then the second function is v. If these are the two functions I am multiplying, and I want to apply the product rule, it means that when it comes to product rule, we know very well that we shall have the y, the x equaling to u, the v, the x, plus we keep the v, then we have the u, the x. Kindly let me know through the chat whether that is something very common to you, to all of you. Is that very fine? The product rule, at least okay. Lydia has said yes, yes, okay. Very good, yeah. Okay, it is very good. Now, in order for us to come up with this technique, what do we need to do, or what do we do? Now, how does the technique come? Now, in order for us, since we are talking about integration, it means that now we are going to integrate both sides of our product rule with respect to x. So I'm going to integrate both sides. So I will come, I integrate this side, and also I integrate this side. So meaning I'll have the integral of the y, the x with respect to the x, because I'm integrating with respect to x, u, the v, the x with respect to the x, then plus my integral of v, the u, the x with respect to the x. Since now I have not changed anything, but I've just introduced an integral. Remember in mathematics, whenever you do something, let me say, in case we have, let me say 2 is equal to x. If you added 2 and you added to this side, you have not changed anything. Otherwise, the thing has remained the way it was, the original thing. So here, us integrating on both sides, we have not yet changed anything. Now, what do we know about integration now? Now, when you look at the integral we have on our right, this integral is going to become our y. Since I'm integrating, there is a silent one. So here we shall remain with y is equal to the integral of u, the v, the x, plus the integral of v, the u, the x. Now, why here, there is a silent one. So that's why for it, we are remaining with only y. Or some people will just tell you what you need to know, that this dy can easily cancel with the integral. But we know very well that our y from our first equation here, from our first step, our y is the same as uv. So where there is y, I'm going to put uv. So I'll say uv is equal to the integral u dv dx plus the integral of v du dx. Now, what is the next step? My next step is making our u dv dx the subject of the formula. So it means I'm going to, since we have already uv is equal to the integral of u dv dx plus the integral of v du dx. So I'm going to bring my v du dx this side such that I make my u dv dx the subject of the formula. So I'll have uv minus the integral of v du dx equaling to the integral of u dv dx. Now, when I write it, I want to just interchange and write it in a very good way. So I'll have u dv dx equaling to u v minus the integral of v du dx times dx. Now, what you have here is what you call the integration by parts technique. And what do you need always to do? When we are to use this kind of approach, always you need to identify, because now this is our new thing that we are going to integrate, which is u dv dx. Now, your u is always that function that is easy for you to differentiate. You look at the two functions you have and ask yourself, which function is easy to differentiate? Now, after noticing that this is the function that is easy to differentiate, you ask yourself, what about the other function for the other second function of integrating? Now, u is the one is going to stand for the one that you can easily differentiate. Then the second one here is going to stand for the one you can easily integrate. So always you are going to identify whereby u is one of your function. Let me say fx, and then the other one is your dv dx, which is the function that is easy for you to integrate. So this is the approach that we are going to use. Kindly, may I know through the chat whether we're on the same page? You can just say yes. I want to know whether we're on the same page. Okay? Yeah, okay. We are somewhere. Yes, okay. So kindly write the formula and then we look at examples. Yeah, write the formula and then we start looking at examples. Write the formula and then we look at some examples. And those who want, you can even show how it comes about just for your personal thing. Okay. Okay. Maybe let me hope everyone has finished. Now we are going to look at examples. Our first example is here. Our first example is here. And I'm going to ask you through the chat to still identify for me two functions. Which one do you think is easy to integrate and which one do you think is easy to differentiate? So mention in the chat. Joy? Looking through the chart, x is easy to differentiate, x is easy to differentiate, and e to x is easy to integrate. Very good. Now another thing you are going to always take at the back of your mind, that particular thing you choose, it must be a function that is going to decrease, to keep on decreasing, not something that will keep on increasing. Take an example. In case you choose to take x for easy to integrate, you'll find that x is going to keep on expanding and becoming much bigger, meaning that it will be hard for you. Now we are going to write our formula, and we say that our integral of u dv dx will always equal to uv minus the integral of v du dx. Now, the first thing, like I've said, we are going to choose which function is easy to differentiate. Now, we have our two functions. This is one function, and this is the second function. So, u is the easy to differentiate. So, I will say u is equal to x. But when you look at our formula here, you are noticing that at one point, you are going to need to have du dx. So we are going to differentiate here and say that our du dx is equal to 1. Now, we go to the second one, which is easy to integrate. Now, the second function, we are going to let it be dv dx is equal to e to x. Now, if this is our function, our interest, because our formula has the v, so meaning that you need to look for v. So in simple terms here, we are going to integrate. So if you can make the x cross on both sides. So when you make it cross, you have dv is equal to e to x dx. And therefore, you go and integrate, you integrate. So meaning that our v will always equal to, now here you remember from your integration that whenever I have I'm integrating, let me say this is our exponential. You know very well that the exponential, whenever you integrate an exponential, you differentiate the power. So I'll have 1 out of a, then I have that original power ax, then plus a constant. So the same thing is going to happen here. We have 2x. So when I integrate it, I'll have 1. When I differentiate, I'll get 2. So I'll have 1 out of that differentiated part. Then after, I write my original thing. Members, are we on the same page? Are we on the same page? Let me know. Okay. 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 Okay, differentiation of exponential. Now, okay, I will take you back. Now, when I have my function, y is equal to e 3x, for you to differentiate this, you are going to use the chain rule. You remember our chain rule. And what does the chain rule tells us? It tells us that the y dx is always equal to the y du, then times the u dx. Now, when you look at our chain rule here, our function is y is equal to e 3x. So I'm going to let my u equals to 3x. And therefore, my y is going to be e to power, my e to power u. Now, when I'm differentiating my du dx, here I'll get 3. When I come to the y, now whenever you differentiate an exponential, it remains the same thing. Whenever you differentiate e to power x, you get e power x. Whenever you integrate e power x, you still get e power x. So it is one of those special functions which when you differentiate and integrate, you get the same thing, given the power as a coefficient of 1. And therefore here we shall have our dy du equaling to e power u. Now when I come back here in our chain formula rule and I substitute my dy du, it means that I'll have my dy dx equals to dy du, which is e power u, then times my du dx, which is equal to 3. But my u, we had it here, it was 3x. So meaning I'll have e power 3x, then times 3. But I can write it in a better way as e 3x, and this is our differentiation. So when you differentiate e power 3x, this is the answer you get. But you well know that differentiation and integration are related. One is the reverse of the other. Now, since we know very well that when I differentiate dy dx, I'm getting 3e power 3x. Now, to get back to our original answer, it means that when you integrate what you have this side on both sides, you get the reciprocal. So, allow me to come here. Let me write it here. Now, you well know that now I have my dy dx is equal to 3e 3x. Now, what do I do? In order for me, because our function of y was 3x, now it means that when you integrate what you have this side, you get back what you had. But the only thing that is not there, that was not there, is this 3. So what you have to do is to remove this 3. So you divide by 3, divide by 3. So that means you have 1 out of 3 is equal to the other thing that you had initially. So that is what I was saying. So what is very important, you need to know how to integrate the exponential. Whenever you have x, when it comes to integration of any exponential, for you what you have to do always, look at the power you have here, that the power is ax. When I differentiate ax with respect to x, what do I get? I'll get my a. So what you do always, you divide. Just say 1 out of that thing I've got after differentiation, then after write the original thing. Then after add your constant. In case it is integral of e 3x. Now this one with respect to x, you'll have 1 out of 3 e 3x, then plus c. In case it is integral of e 6x dx, for you differentiate 6x, I'll get 6. So say 1 out of 6 e 6x, then plus c. Even if it is 3 and you are integrating 3e7x, maybe something like that, still you do the same. For you, go on and first differentiate the power. That the power is 7x. When I differentiate 7x, I'll get 7. So I will say, now, but since I have this 3 here, I will say 3 out of 7 is 7x, then plus c. May I know through the chat whether we're on the same page? Are we on the same page with? Okay. 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 Now, let's go back and now continue with our number. So, like we have said, that here our formula, we shall have uv integral v du dx, then times dx, and this one will always equal to our u dv dx dx. Now we have said that we shall let our u equals to our x, and therefore du dx will equal to 1. Then our second one, dv dx, is equal to exponential of 2x. But like I've already told you, here you are going to just integrate both sides. And therefore, when you integrate this function, we have e2x. We have agreed that we shall have 1 out of 2 e2x. Now, the next task for you to do is to get what you have summarized and substitute in the formula. Where there is u, put what is going there. So when we come back to our formula, we shall have uv minus integral v du dx dx. So our u, we said our u was x, I will say x. Our v, we have obtained it as a half e exponential 2x minus the integral. Our v was 1 out of e 2x. Then your du dx, when we differentiate, we got our answer as 1. So here I'll say times 1 dx. Now I'll continue and say, now here always it is good to start with the constant. So I'll start with 1 out of 2 x e 2x minus here I have a half e 2x times 1. Anything times 1, it is the same thing. So allow me to pull out a half, and then I'll have e 2x dx. Now my next thing is for me to go on and I integrate again what I still have. Can you tell me the answer through the chat? When you integrate exponential e to x, what do you get? I'm asking when I want people to integrate this now. We have remained with e to x. So when we integrate, what are we getting? Or what do we get? Does it mean we are not yet there? Okay, e to x. Okay, now here we shall have 1 out of 2 x e to x minus this a half we have. But like I've already told you, whenever this is just side work, whenever you meet an integral of EAX, this is the same as 1 out of a EAX, then plus a constant. Even if, by the way, even if this power was, let me say, was EAX squared dx, still it is the same thing. For you integrate this, what do you get? You get 1 out of 2AX, then EX squared, then plus C. So do not mind about, as long as for you, you go on and differentiate. So here I will have times, what I get here is going to be a half e to x plus c. So here we shall continue and say this is a half x e to x minus a half times a half will give us a quarter of e to x plus c. And this is now our answer. Members, are we on the same page? Are we on the same page? Kindly let me know. Are we on the same page? Yes. Yes. Okay. 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 I think okay. Okay. Fairly a bit. Okay. We are still doing. So we are going to do another one. We are going to do another one. Can I remove or people are still writing? Let me know. Can I remove or not yet. People, okay, wait. Okay, let me wait. It is okay. Yeah. Yeah. I'm not going to use the table approach. Yes, but you can, if you know how to use it, it is very okay. The reason why I wouldn't love us to use, it limits your creativity. And in case of just one mistake, it is very easy for you to be off. Just missing a plus, you can be off completely. Even much as if also this one, but this one will help you to develop your techniques in the subject. Yeah, to develop very many other techniques, the techniques of factorizing, techniques of what, and the rest of that, compared to that table format. But maybe at the end of the lesson, I can show those who are interested on to use it, but it can as well work. Okay. Okay, I think people are finished. We can try another one. Now, the second one we are going to do, allow me still to move in the same direction first, and then we shall deal with different functions. The second one, we are going to integrate. We have the integral of 3x. Should I? Okay. Let me know people have not. I want to, we are going to integrate our x e 3x dx. Yeah. Now I'm still taking you in the same direction, but different digits to bring out the concept first. Now still, first identify what is your u and what is your dv dx. So I'll say my u is x and my dv dx is going to be exponential of 3x. But whenever you are dealing with exponential, write it somewhere that whenever I have an exponential ex dx, I will always get 1 out of a e ax plus a constant. So still here, our v, when we integrate, we shall end up with 1 out of 3 e 3x. Because here, when you look at this is our power, is like your ax. So when you go on to differentiate it, you end up with a 3. So which will turn up to be 1 out of 3. Then at this point, now we are going to continue with our formula, which will say u dv dx will equal to our uv minus the integral of v du dx times dx. Then we are going to feed in our u, here was x. Then our v is a third e 3x minus integral of v, which is 1 out of 3, e 3x, then times du dx. Since we have said u is equal to x, meaning that du dx will equal to, when you differentiate x, you get a 1. So here there is times 1, but anything times 1 is that same thing. So allow me to just say dx. Now when I reach here, I'll say a third x e 3x minus, since this third is a constant, there is no problem. You pulling it out and you remain with e 3x dx. Now you go on and integrate this exponential. So when we integrate, we shall notice that we shall have a third x e 3x minus a third. Then what is inside the integral? E of 3x, we have agreed that this will be 1 out of 3, e 3x, then plus a constant. Then you continue and simplify it as a third x, if 3x minus a third times a third gives us 1 out of 9, e 3x plus a constant. Members, are we on the same page? Are we on the same page? Okay, people are saying first, one person saying first, go through it again. Okay, let me first answer some questions. In case you have a question, raise up your hand. Yes, Stella? Unmute. Stella?
Excuse me, teacher.
Mm,
Teacher.
yes. Yes,
I
please.
was asked,
Mm,
like, where you've written, where you have integral of u dv over dx equals to uv minus integral of v du dx. Is it du or dv?
okay. Let me, yeah, this on our here, I think this side, it is dv dx. Then this side is du dx. I don't know the style you've got. On your left, you'll have dv dx. Then on your right, you have du dx.
Okay, teacher.
I don't know. It came from the way we derived it. That's where it is coming from. Yes, Garland.
Master,
Mm.
my concern is about those who are writing that
Mm.
at least let's be just taking screenshots. We shall write later because writing is going to take us a lot of time, yet you have a lot of things to cover, sir. This is what I was
Okay.
just suggesting.
Okay. Okay. Thank you. Okay. Yes. So that formula, but also in those logbooks you have, yeah, that formula will always be there. That formula will always be there. Okay. Okay. I think we can continue and we see, as long as for you are able to identify those two things and your techniques of integrating are good or differentiating, then it will be very bit easier for you. Okay. I can have another one. I have this as 5x e x dx. Can you let me know through the chat what is going to be our u and what is going to be our dv dx? Type in the chat and we see whether we can now identify at least those two things. What is going to be your u and what is going to be your dv dx? 5x is our u. Very good. At least that is very okay. That is one step that we are somewhere. And meaning that what is remaining is going to be our dv dx. So here we shall have ex. Now, what you do, you differentiate the way we differentiate. So here we shall have du with respect to x. So when I differentiate 5x, remember your differentiation. Our power here is 1. So I will multiply my power, I'll get 5 times 1. Then I reduce my power by 1, I'll get x power 0, which is 1. Then this side, when I integrate, we shall have our v is equal to ex. Then after, go to your formula. So our formula will be the integral of dv dx will equal to our uv minus the integral v du dx. And now we are going to substitute. Our u is 5x. Our v is ex minus the integral of v, which is ex, times our du dx, which is a 5 dx. So here we shall say this is 5x ex minus. Here when we write it well, we shall have 5 ex dx. But you know that the moment you integrate e power x, it is still the same thing. But it is always a good practice. You first factorize out the 5 if you are not sure on how to deal with it. So I will say 5x ex minus 5 integral of ex dx. And therefore, this we shall have 5x e power x minus 5. When you integrate e power x, it is the same thing because when you differentiate x, you get 1. So 1 out of 1, it is the same thing. Ex plus a constant. Yeah, I saw a hand up. Okay. Members, are we on the same page? Have we started picking? Are we picking something? Yeah. Okay. Okay. Let me. Okay. At least people. Yeah. People are picking. Okay. Let me. Yes. Trinomugisha Elvis.
Yes, Mr. Now, you've said that when we integrate e to the power x, it remains the same. So doesn't it make it the easy one to integrate? What if I use my u as e to the power x?
Now, what
Will
is
it
going to
be
happen? When you use your e to power x, yes, that's why we have used it. We have taken it.
No, what I'm meaning is that when I use the e to the power x as u, is it correct?
Oh, now what is going to happen when you go that way? Allow me members to show what will happen. Now, if you choose wrongly, and let me say you say your dv dx is 5x. Then you say your u is ex. Right, you are going to integrate here and you'll get 5x squared out of 2. Then here you'll get your du dx is equal to ex. Now, when you come to substitution, you'll have your u as ex. Then your v is going to be 5x squared out of 2 minus the integral of your v, which is 5 out of 2 x squared ex, then dx. Now, here, what is going to happen? You are going to continue. Every step you go on, you are going to find yourself that the power of x is increasing. And that means you are going to have to integrate this again using by parts. You go on using by parts. So you'll be doing something that is not ending. And you'll find yourself that you have an integral going on over and over. I don't know that that person has picked it. That's what will happen. Whenever you choose wrongly, you are going to find yourself that the number is not ending. You are integrating, but things are still there. That's what will always happen. So choosing correctly is very important. That's why when you are choosing, make sure that part has a decreasing power. That when you are reducing it, you will see it dying on the way. Okay. Yes, though for some numbers, here you can apply, by the way, integration by parts for at least 2 or 3 times. But the moment you find yourself going into 4 times, 6 times, what? Just know there is something you are not doing well. Yes, Caesar. Okay, Caesar.
I want to add something on what you're saying here. There's a formula which leads you to integrating such splitting of such expressions. Now, I have a formula here which is LIACE, in which each of those letters have a meaning. Like you write here, LIACE, where the L stands for log. Anyway, when you see log in such in that number, you start with it. It will be u, and this I is your inverse function. When you also find inverse any number which is inverse, you deal with it first. And the A is algebra, and the T is trigonometrical function, and E is the exponential. So if to look at L and I, L comes first. It means you pick L, which is the log, you pick it first before the other one. So this L will be your U, and I, if I is also there, the inverse, it will be your, it will now be the by the X. Now, if you have to look from the recent question we are just doing here, we have A, which is the algebra. The algebra comes before the what? The exponential. That's why A is second. The algebra, which is 5x, is second first, L is U. And E comes after A. It means you consider A as your U and E as your divided by the X. That one simply is the best way I always do mine. Thank you.
Okay, thank you. Yes, that approach is okay, but always my worry is on the cramming. Yeah, what at times will happen when it comes to math and when you advance at advanced levels, you'll find that some of those formulas you come with at this level, most so if they are not internationally recognized, you'll find that you may find yourself that you have crammed something, and to remove something maybe you had crammed, it takes a lot of time. That's why here I am encouraging understanding something from the basics. Then I want you now those formulas that Caesar you are mentioning, that word, I know it, LIATE, I know it, but I want that one should come as your personal initiative, that when I read something, for me to do it, this is the approach I can use, but I cannot give it here as a general thing because I will be teaching you to cram instead of you now understanding, but such that when you sit down and do quite a number of them, you can as well be able to come up with yours. Otherwise, when we give it to you here or when you have it here, it will not help you to be creative, that you can think of something that even that can work for you. Yeah, that's why I don't want to use it here. I want you to understand. Then as time goes on, I want you to start thinking, depending on how many numbers you have done. Because the more numbers you are going to be practicing, the more it will be easy for you to start figuring out things that when I meet this is what I do. So I want you, if you can as well think about something that can help you to remember what you have read. So that's why I really do not want, but I know it exists in formulas, but there is no an internationally recognized book where you may meet it. But it is okay if you have already mastered it, but I will encourage always to learn to create your own knowledge, like your own formulas that can work well with the mind. Yeah, that's my submission, but it is very correct. Okay, Peter?
Teacher, I need some help on this part of v is equal to exponent x. Why are we not putting plus constant?
Okay, now since this integral is still continuing, we are not, this C combines all those constants. That's why we don't want to carry it. I don't know that it is fine. For any constants that you have in the process are being catered for by this. Okay, one more question. Sandra?
Yes, good afternoon, sir.
Good afternoon.
I'm having an issue on this part of the equation whereby we are having uv minus, of course, the integral of v du dx dx, okay? Now this part whereby we are filling in on the part of uv, why is it that on u we put the value of u exactly, that is the 5x, right? Then now on the part of v, we instead use the v dx. That part is the one that is confusing me.
No.
I thought maybe we would put.
Okay, Sandra, before you go on, Sandra, you can notice that when we integrate EX, we still remain with EX.
Yeah.
Because this exponential function, it has a bad behavior. For it, when you integrate, it remains the same. When you differentiate, it remains the same. So that's why for it.
Now, this is the case with basing even on the past examples. That is where I'm getting the problem with. Even from the past examples, for instance, this one where this one that we've just done before this one, whereby our u was x, okay? Then on the part of filling in v, we instead put the value of the v dx.
No.
So that's what I'm getting
Look
confused.
here, Sandra, are you looking?
Yeah.
Our value of v was a third e power 3x. And when you look here, you can see that we substituted a third e3x.
Yeah.
Are you not seeing
Okay,
it?
now I think. Yeah, I notice it.
Okay. Okay. Let's continue. Now, those were exponential functions. Now, we are going to go into what if we find natural logarithms? But as we approach the natural logarithm, now, what is very important? Do you know how to differentiate a natural log? That is very important. Now, I'm going to first remind you a bit that when I have y is equal to ln x, many times when you meet, it is one of the hardest things to integrate is ln of x. It is not something you'll just visualize and integrate. So meaning that when you meet a natural log, check out, can I integrate a natural log? That probably no. So meaning that when you meet it, it is the one that is going to be easy for you to differentiate. But how do you differentiate it? You need to remember that I can say let my x be my u. Then you go back to the chain rule that my dy dx is the same as dy du, then times my du dx. So what shall we have? I have x is equal to u, meaning that our du dx will equal to 1 because the moment you differentiate x, you get that same thing. So dy du, I go back that my y is equal to ln of x. But since I've already let x equals to u, I'll have y is equal to ln of u. And one thing you need always to know that whenever you have a natural log of just x or u, it is the same thing. So I'll have it is dy du is equal to, may I know through the chart, when we differentiate ln u, what do we get? Let me know through the chart. Let me see whether people remember. When you differentiate ln of u, okay. You get 1 out of u. So here we shall have 1 out of, let me see, what do you get? 1 out of u, 1 out of u, 1 out of u. So that is now very, very important. So those who don't know how to integrate it, you need to know how it is being integrated. So now we shall have 1 out of u. So when I come back here and substitute, I'll have dy du, which is 1 out of u, then times my du x, which is already 1. So I'll end up with 1 out of u, but my u is the same as x. So I'll have 1 out of x equaling to dy dx. Now, what do I want you to know is that whenever we have a natural log, this one didn't bring out the thing I really wanted, but I can go back and I show you. In case it was maybe x3, what are you going to notice? Allow me to go back such that members just know that when it comes to natural log, when we are differentiating, the most important thing is what we have here as our u. You need to know how do we differentiate it. So here still I will say my u is x cubed and my y is going to be ln of u. So meaning that our du dx is going to be 3x squared. And our dy du is going to be 1 out of u. So when we substitute back here in our chain rule, where there is dy du, we shall put 1 out of u times where there is du dx, we shall put 3. We are going to put our du dx, we shall put that we have it as 3x squared. But you need now to know what is your 1 out of u. Then, but still remember, you had related your what? You had already related what your u is as x cubed. So you put here and then you go on to reduce the function. So that is where we are going to start from. That is where we are going to start when it comes to this kind of integration when we meet the new. Now, what are we going? Oh, okay. It seems some people are not getting how we integrate natural logarithms. Okay, natural logarithms. Yeah. Okay, just give me a minute. Oh, sorry. I've been talking, not knowing that I muted myself. But have we been following? Have we been following, or I have to repeat? Okay. Okay. We repeat. Okay. We are going to repeat another one. Yeah. Sorry, I muted myself. So I have y is equal to, let me say, ln of x power 7. This is what I want to integrate. What am I going to do? The first thing, always, what is inside here is what you are going to let. So you'll say my u is equal to x power 7. Then you say, what is my du? I'll say my du dx will equal to 7x power 6. Then I go back. My y now will become ln. Since we have said x power 7 is u, so this will be ln of u. But one thing I want you to get at in your mind is that whenever you differentiate ln x alone, always your answer will be 1 out of x. Always. Now here when I have y is equal to ln u, so where there is u is what we have as our x. So here instead we shall have dy du is equal to 1 out of u. So what do we do? Now I will come back and I say my dy dx will equal to dy du times du dx. my dy du is 1 out of u times du dx, which is 7x power 6. So this 1 out of u, our u is x power 7. So I'll have 1 out of x power 7 times 7x power 6. Then I reduce the powers. Up there 6, down there 1. So, or you can use your indices that this is you can use your indices that powers I subtract, then you get x power negative 1 if you want. But if you can, up there 6, down there 7. So you end up with 7 out of x. First, let me know whether now we are somewhere. Let me know whether we are somewhere. Understood, understood, understood. Aha. Okay, now since we have understood, let me now make it a bit better. Now, whenever you find that the digit that is with the ln is not to power 1 and it is to any other power, this is what we shall always do. That always you'll have d dx of ln of that particular function, let me say of fx. Always what you do, differentiate that function, yes, then divide by the original function. Differentiate that function, divide by the original function. Take an example. I come here in peace. I have d dx ln of x power 7. Now for this particular one, our function is x power 7. I'm going to differentiate it. That is f prime. So I will say 7x power 6. After I divide by the original function, which was x power 7. When I reduce, these are 6, these are 7. So I'll get 7 out of x. Let me know whether you have picked that now. Is that fine? Yes, Tabitha is saying yes. Okay, very good. This, okay. Now to test whether we're on the same page, you're going to do for me this one. Ln 2x, differentiate for me that. Ln 2x quickly. And we see which answer you have. I've said, oh, Lydia has not picked and taken. Lydia, I repeat for you. We have said that when I have ln of 2x, whenever you find that here what you have, is this is your function. So what you do, differentiate it. So I will differentiate 2x, I'll get 2. After, I divide by the function I differentiated, which is 2x, which will give me 1 out of x. Alternatively, use the rating of y is equal to u. Yes, alternatively. Okay, can you do for me this now? Because this concept, we are going to use it. Ln of 4x minus 3. Differentiate it for me. Differentiate ln 4x minus 3. What do you have? Okay, at least I've seen we are getting there. We are getting, very good, very good. Okay, okay, at least we are there. What about, now some of you are going to say, what if they gave us this? I want to see how people are doing it. What if you have this? What if you have something like that? Yes, at least I'm seeing people getting there. We are going to get there. What if we have that? Tabitha, kindly check your answer, Tabitha. Okay. Let me hope now we are good to start on our number. How is it happening? We are saying how. I've told you. This one is just a constant whenever you are doing the differentiation. So leave it outside. Then for you, concentrate on the ln alone. So when you concentrate, we have said, I will differentiate what is inside. When I differentiate, I will get -1. When I divide it by the original is 1 minus x. So which is -5 out of 1 minus x. And if you want, you can as well write it as x minus 1. 5 out of x minus 1. Oh, I don't know whether we are. Why is the 5 negative? 1 minus x. 1 minus x. You remember you have 1 minus x. When I differentiate 1, I get 0. When I differentiate -x, I remain with -1. Members, are we on the same page now? Are we good to continue to start now using integration by parts for natural logs? Okay, very good. Yeah, okay. Okay, now we start. Now, what do I have? I have integral of x squared ln x dx. Let me check whether Diana has a burning question. Yes, Diana.
So what if I take my ln -1 to power 5?
Oh, yes, it is also fine. But you'll get the same answer.
Okay, sir. Thank you so much.
Have you tried it? Did you get a different answer?
No?
Yeah, okay. Maybe let me just, oh, no. Let me note that in this place. Yes, so if you take it that way, for you, you'll have ln 1 minus x power 5. When you do what? You differentiate, you get 5 into 1 minus x, then times -1. Out of, then here the power is going to be 4. Then out of 1 minus x power 5. Then these are 4 powers, down there 1 power. So you get 5 times -1 out of 1 minus x to power 5. Yes. So, but sorry, remember these were 4, down with they were 5. So here down we remain with 1 power, which is -5 out of 1 minus x. So you get the same answer. But that means you need to be very good at differentiating. You need to be very good at differentiating because 1 minus x power 5. You remember, you drop the power, reduce the function by 1, then differentiate what is inside, which is -1. So if you don't know, then it might be a bit tough for you to reach the same answer. Now, what are we going to do? We are going to use the same approach. We are integrating by parts. Now, here, this is where now you need to be very selective. You ask yourself, which one is easier? I've told you integrating ln is not easy. So it's what is going to be our u. So I'll say u is equal to ln x. Then I'll say my dv dx is equal to x squared. Now, we are going to get du dx. Here, I think now you can agree will be 1 out of x. Then I integrate dv dx is equal to x squared. So remember, when we are integrating, we add a power, we divide. So here our v will equal to x cubed out of 3. Members, through the chat, are we together on that step? Is that step good? Okay, perfect. Yes, Galona. Yeah, please. Yes, please, yeah, don't mind about the constant. For when it comes to v, that constant, we consider it at the end of the expression. So don't look at it here. Yes, ignore it. That a constant, for that part, it is 0. Now, Rita is saying the v dx is confusing me. Okay, let me just show you how it is worked out. Now, when I have dv dx is equal to x squared, you know, mathematically, I can multiply this side by the x, this side by the x. meaning I'll have dv is equal to x squared dx. Now, since I want v, I'll integrate with respect to x. So this one will go with that, so you get v. In other words, there is a silent one here, which now people were asking, I think, let me show it from here. I think this one will make the work a bit easier. So here you'll have, we shall remain with dv is equal to x squared dx. So when I integrate and I integrate, remember there is a silent one here. So since I'm integrating with respect to v, I'll have v is equal to, this side, I have an integral of x squared. So I'll get x cubed out of 3. But since also this side I'm integrating, I'll have a constant. This side I'm also integrating, I'll have a constant. So these constants cancel out. So you remain with v is equal to x cubed out of 3. So that's why we don't consider those constants for this particular one when it comes here, until when we reach the end. Okay. Hope now that is okay. Is that fine now? Okay. Okay. Now we are going to go now to our formula. So our formula, we know it very well. That now we shall have our uv minus the integral of our v du dx times dx. And this one is what gives us x squared ln of x dx. So what is going to happen? We substitute our u, we had it as ln x. Our v is x cubed out of 3. So I'll write x cubed out of 3 ln of x minus the integral of v, which is x cubed out of 3 times du dx, which we have as 1 out of x, then dx. Now here, members, I want you to take note that I didn't want to write to here. Remember, this is multiplication, so you can easily interchange. I didn't want to write like this. Why? Some of you are going to confuse and go and say, x times x cubed, I get x power 4. Yet these are two different functions. So that's why I didn't start. I didn't start with the natural log, but I started with the other function. Now, when it comes here, I think members can see that this x and x cubed are going to reduce. So I'll have x cubed out of 3 ln of x minus the integral. Here, I'll remain with x squared out of 3 dx. Since the up there were 3 and down we have 1, they reduce to only 2 x's. Now, when you reach here, you notice that you have to integrate. So I'll continue and I say this is now x cubed out of 3 ln x minus. When I integrate here, remember it is also okay for you to pull out that unknown, x squared dx. Then you know that when I integrate x squared, what do I get? So we shall continue and say this is x cubed out of 3 ln x minus 1 out of 3 x power 3 out of 3, then plus our constant. So which you can simplify as x power 3 ln x minus 1 out of 9 x power 3 plus a constant. In case you have not understood, there is a burning question, kindly let me know. Yes, Diana, I'm seeing your mic unmuted. Is there anything?
No, sir. I'm good.
Okay. Is everyone good? Are we good? Are we good to... Mhm. Mhm. Okay. Members are saying at least they are somewhere. Allow me to give you a number in the same caliber. The number that we are going to do is now this. Integral of natural log x dx. Now, like still we have said, integrating natural log, you may look at it like that and you find that they have put for you 5 marks and you think, it is something. It involves you using integration by parts. Now here we have a 1 that is silent that we are not seeing. So there is a silent 1 here that has not been put. So meaning that when you are letting, you are going to say, my u is ln x. My dv dx is equal to 1. Members, is that fine? Yes, okay. Okay, yeah. Now we are going to differentiate. So I'll say my du dx is equal to 1 out of x. And when I integrate here, I'll have my v is equal to x. Here, do not forget that here there is an x power 0. So when you add a 1 and divide by 1, you end up with x out of 1, which is the same as x. So do not forget that, or don't forget it. Now, after I go back to my formula and I say now, integral of ln x will equal to my u dx will equal to my uv minus the integral of v du dx times dx. My u is ln x and my v is x. So allow me to write x ln of x minus my integral of v, which is x, times my du dx, which is 1 out of x, then times the x. So you can note that the x and the x are going to reduce. So meaning we shall remain with x ln of x minus. So the 2 are going to reduce. So I remain with only 1 dx. Then I will continue and I say this is x ln of x minus x plus a constant. So whenever you meet ln of natural log of x, for you to do what? When you integrate it, that is the answer you get. Any question? Anyone with a question? In case there is something you feel you want to know, you want to ask. Okay, people are saying no. Okay. Okay, let me pick Diana. Diana has something. Yes, Diana?
So why is it that in our expression, the integral ln x, you let the second element to be, okay, you let the silent one to be our element v, and then you let the ln x to be our element u?
Yeah, the reason is, Diana, integrating ln x is not easy. It's not, let me say, it's not something obvious that we can find out. Yeah, so that's why we always look for which one is easy to integrate, which one is easy to differentiate. So if you, for you, you just come out and say, this is this, you'll find out. But still, even when you know how to integrate ln of x, you are going to notice that the thing you have chosen for integration, its power is going to keep on increasing, increasing, increasing. So you'll find yourself having a lot of things you are integrating that are not ending.
Okay, sir. Thank you so much.
All right. Okay. Yeah. Always pick out x plus. You want to put a bracket? Maybe here. It is okay putting a bracket. Okay. I think now we need to try out numbers. Oh, I've not yet done. I don't know whether you still have energy. I first do, it is up to you. Either we can first try out 1 or 2 numbers on our own before we go in for trigonometric functions. Or now, in case you want to first try out, put in the chat yes. In case you feel that we need to first finish trigonometric, then we try at once, then also We first try out. Okay, people are saying we try out. We try out. Okay, you can first try out. Yeah, we are going to try out. Yes. Now, which ones are we going to try out? I'm going to choose for you. This is one of them. Hoping we have not done a number. So we start with this number. That is what we are starting with. Our second number that we shall try out is going to be this number. Those are the two numbers we are trying out now. But first do part C. First do part C, and then we do it together. Then we agree whether our answers are okay. We are trying. We are trying and see. Some answers have started dropping in the chat. Some answers have started dropping in the chat. Okay. I've seen Rona has got some answer. If you get your answer, feel free to drop it. And be confident and drop it. Blessing. Yeah. Share it in your chat, in the chat, then we can look at it. Yeah. Okay, Blessing, let me know. When I tell you to look at your answer, there is something still that needs to be looked at. Blessing, first look at your answer. Yes, Lona, also look at your answer. Morris, look at your answer. Okay. Caritas, look at your answer. Okay. Members, let me know through the chat whether everyone has tried, and now we can do it as a team. Let me know through the chat. Some people are stuck. Precious, look at your answer. Lydia, okay. Someone is stuck. Okay. I want you to just let me know. Okay, Blessing, yeah. Not yet. People are still working. Brighton is a bit stuck. Okay. Liz, okay. Okay. So 1 more minute. Okay. Okay, I think we can look at it. X linked to X. Okay. Have X linked to X dx. Now we always start with our rating. So we shall say our U is going to be our link to X, and our dv dx will be our X. And now we are going to differentiate. So here we shall have du dx. We have said always get what you have here, differentiate it. So my answer will be a 2. After I divide by the original function, which was 2x. And here when you reduce, you get 1 out of x. Then I come here. When I integrate, I'll have my v equals to x squared out of 2. Now after doing so, I come back in the formula I substitute. uv minus v du dx dx. So here I'll have my u as ln 2x, but I've told you it is always a good practice to start with this, the one that doesn't have ln. To avoid cancelling, you may make a mistake and cancel. So allow me to start with sorry about that. Allow me to start with, in fact, all of them are okay. allow me to start with the v, since I may easily confuse it with what I'm supposed to cancel. So I'll start with x squared out, okay. I'll start with x squared out of 2 ln of 2x minus the integral of my v, which is x squared out of 2 times what I have as my du dx, which is 1 out of x, then everything with respect to dx. So when I continue, I'll have my x squared out of 2 ln of 2x minus I reduce. This x will reduce with one of the x, so I remain with x out of 2 dx. So here I'll have x squared out of 2 ln 2x minus, here I'll have 1 out of 2 integral of x dx. So which will end up with x squared out of 2 ln 2x minus 1 out of 2. Then I integrate this. So I'll have x squared out of 2, then plus a constant. So when you look at what we have in the denominator, it is 2 times 2, which will end up with a 4. So I have x squared out of 2 ln of 2x minus x squared out of 4 plus a constant. Can we check now where we made the mistake? Those who have, Lydia, I saw you with 16, people who had their 8. Have you seen where the mistake was? Okay, people have seen, yeah, okay. People have seen the mistake. Okay. Let me share. Oh, I don't know whether people had finished. Have you finished? We continue. Okay. We are trying another one. We said we are trying 2 numbers at least. Part E. Okay. People are still trying. It is okay. Okay. I feel we have got some answer. Yeah. So you can also compare to what your friends are posting. Okay. Okay. Yeah, it seems people have got some answer, and we are good to try it out and see what we have. Now, and see what we have. Now, I think people were sending me the one of 16 started with part E. Let me hope x power 3 ln x. Okay. So we have x power 3 ln of x dx. Yes, Techno. Unmute. Techno. Someone can raise up the hand and you take us through. Yes, Techno.
Yeah. Me, I'm from another school, but about this differentiating, I've been trying to pick up because at school we had started integration, but when it comes when you look at this in the first number, when you look at where you got the v, the x, I'm really not getting.
Did you join
Because
in a
I've
bit
been
late?
trying. Yeah.
Oh, yeah, that's where the problem is, because I had showed members on how we come up to that point. Yeah, but maybe I'm going to be sharing the recording such that you can start from the beginning, but at least be following such that you can easily relate. But you needed to first know how we got up to there. But hope you did a product rule at school.
Yes.
Yeah, so that is where we started from. That product rule, when you integrate it on both sides, you come up with that formula.
Okay. Thank you.
Okay. Yes, Lydia.
Teacher, for me, I just wanted to take you through the number.
Yes, let's start.
Yeah, we let ln of x to be u. Then the dv dx to be x power 3.
Okay.
Then we go and we differentiate that ln of x and we get du dx, which is 1 over x. Then we integrate dv dx to get v, which is 1 out of 4 x power 4. Then we substitute in our formula, which was integral of u dv dx x.
Yeah. Yeah. Okay.
And then when we substitute, we shall get the other answer.
So here we shall have
Ln of x
okay.
minus integral of a quarter x power 4 times 1 over x dx. Then 1 over 4x power 4 ln of x minus 1 over 16 after integration.
Yeah. Allow
1
me
over
to
16. Okay.
yes. 1 out of 16, eh?
Yeah, after integration.
After integration. Okay. X power.
X power 4
All right.
plus.
Yeah. Thank you, Lydia. Yes, members. Okay. I think that is very okay. I want to test, kindly let me know through the chat whether you have energy. We look at the trigonometric part or we have it next week. Let me know through the chat. Now how are you going to differentiate your responses? Those who are saying we continue, say just continue. Okay. 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 Yeah. Okay. 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 It is well. It is well. Since I am seeing the people want us to have it and many, we can. Good enough. Good enough. There's something I want to save. Good enough. The beauty is, it is because for us to be able to do the exercise well, you need, and yes, I want you to, we are going to have just 2 numbers and it is the same principle. The only thing that we need, people must be able to know how to differentiate those trigonometric things. That is the only thing that we need. But just know, you are going to see life very easy. They are also very easy and doable as long as you remember on how to do the differentiation of the trigonometric function. Yeah, but now I can even test and ask you in the chat, put for me, when you differentiate sine, what do you get? When you differentiate sine, what do you get? When you differentiate sine, what do you get? Those who have done differentiation of trigonometric, when you differentiate sine, looking through the chat, cos, very good. Yeah, as long as you know that one is like the mother. The moment you know the mother, the rest are very okay. But allow me also to remind you. So when you these are going to be very key. The moment you have the x of our sine of x, here you'll always get your cos x. Whereas when you have the x of cos of x, here you'll be getting your negative sine of x. Yes, then for integration, the opposite is true. For integration, you just interchange. When you integrate sine, you get negative cos. When you integrate cos, you get sine x. That is the only difference. Then the other things will remain the same. Now, what is going to happen? What is going to happen now? But let me not assume everyone knows. I know some of you may not have done this. So this is sine x plus c. Then when I have sine of x dx, here I'll end up with negative cos xc, then plus c. Those are the major ones. Then the rest of the things that you are going to be doing, they will be originating from there. And now, what is our first number? Now, our first number of integration is going to be integral of x cos of x dx. Through the chat, members, let me know what do you want, what do you feel our u should be? I'm just testing to see what do you think our u can be? Our u, what? I'm saying yes, yes. Okay, some people are saying cos, others yes. Now remember our u, your target always should be that I don't I look at in a direction where my things are going to reduce, not increase. Yeah, so you need to look ahead. So when we meet trigonometric functions, always the easiest one to let for your trigonometry, your u can be the x, whereas your dv dx can be the cos of x. Now, the other part, always, for you're going to try out when you go back and when I let this and this, will it come out? So here, you know, my du dx is going to equal to, oh, sorry. Here, it is equal to 1. And I know my v from here. We have said that when we integrate cos, we get sine. So here, I'll end up with sine x. Then we go to our formula. uv minus the integral v du dx dx. And this one will be giving us our integral of x cos of x dx. So what is our u? Our u is x. Our v is sine x minus the integral, our v, which is sine of x, our du dx is a 1, then times dx. So here we shall end up with having x sine of x minus. When you integrate sine, you get negative cos. So here I'll have minus cos of x, then plus a constant. So I'll end up with x sine of x plus cos x plus c. Members, have we understood that? Have we understood? Okay. Okay. Kathy, and Tekino. There are some people I've seen. Yes, Tekino. Your mic is unmute. Let me know. And Kathy, unmute.
Master,
Yes.
where about this, when you differentiate v and then du dx, this part up, how do you come up with this?
Yes, like
X and d.
yes, I earlier on I told you when I have the v dx is equal to cos x. This one, when you simplify it, I can multiply by the x, I multiply by the x. So when I do so, I remain with dv is equal to cos x dx. So when I integrate this side and this side, here, since I have a silent one and I'm integrating v, I'll end up with v is equal to, when I integrate cos with respect to x, just come here, you'll end up with sine of x. But I've told that since you have to add a constant this side and a constant this side, so that's why we ignore the constants.
Okay.
Okay. Yes, Kathy? Okay. 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 Good.
All right.
Now, yes?
I have got it.
Oh, okay. We try another one. Oh, we try another one. But even I think this one we can give it a try. Yeah, I'm sure some people can. Oh, wait. This one we are trying it now, much as we have done one example. Do it. First try. This is going to be our last number. The rest I'm going to leave you to try them out. Yeah. Though we still have a long way, but at least try this. So we are Let me hope now we have tried. X cos 2x. Plus sine. Okay, precious. Okay, I've seen varying answers. One which has showed me we have a challenge with differentiation. We have a challenge with integration as well. Yeah, because many of you know what to do, but integration has failed us. Yeah, that is where now the problem is. Yeah, integration has failed almost all of you. Yeah, okay. Now what we are going to do, allow me to do this. I'm going to take you back to differentiation. I want to emphasize what we call the chain rule. When I have my function, this is our function 2x, and I want to differentiate it. This thing is will help you a lot. Say, this angle here, whenever the angle is not a single angle and there is a digit, the way we differentiate is not the same thing where we differentiate here. So I expect you to know that here it will say is equal to sine 2x. So you go on and differentiate. So this will be the u. Okay, sorry. Okay, allow me to first move. So our u is the angle, the double angle you have. So I will say my u is 2x. So when I differentiate, I will say du dx will equal to 2. Then I'll have my y is equal to sine. So where there is 2x is where we are going to put u. Here. So I'll say this is sine u. So when I differentiate, I'll have the y, the u is equal to. Now, when sine is just a single angle, the other thing works very well. So this is the same as cos of u. Then after doing so, go back to your chain rule. The y, the x is equal to the y, du times the u, dx. So what is this one going to equal to? The y du is cos u times our du dx, which is 2. So which you can write it as 2 cos of u. But what was our u? Our u was 2x. So here we shall get 2 cos of 2x. So that is the integral. So when you differentiate d dx of sine of 2x, what you get is 2 cos of 2x. When I differentiate d dx of, let me say, cos of 2x, what do you do? In other words, I want you to, what do you do? I will come, okay, let me do like this. Can I just say, this thing you are not seeing here, it is what you went on and differentiated. So I'll only differentiate the angle. So when I differentiate the angle, my answer here I'll get is 2. Then I go on and I differentiate the function. My function is cos. So it will be sine, but since when you differentiate cos, you get negative. It will be negative sine, then put back the angle. In case it is d dx, and you are differentiating, let me say, cos of 3x. For you, what you do, differentiate the angle. Which answer do I have? When I differentiate 3x, I will get 3. Now, differentiate cos. What do you get? I'll get negative sine after put the angle there. Even if it is d dx of maybe sine of 8x, still do the same. Differentiate the angle. It is 8x. When I differentiate, I'll get 8. Then differentiate sine, which is cos, write the original angle. First, let me know whether that one now is in the head. That part okay for just differentiating before I bring in now the integration. Okay, it is there in the head. Okay, good. Now, can I write a general formula for you? Now, generally, what does it mean? Oh, but it might bring for me problems, but it is okay. No, but since you have learned, I will give you an exercise to test it. Okay, now that one is okay. Now, what do you need to know? Like we have said, always differentiation and integration work hand in hand. So I'll come back here. ddx of sine of 2x. We have said when we differentiate, we end up with 2 cos 2x. Not so? Then we have also noticed that this is what we end up. But also you have noticed that when we differentiate ddx of cos of 2x, we end up with negative 2 sine of 2x. So if I want, whenever I see sine, it means that the function that was differentiated was a cos. When I say cos, it means the function that was differentiated was a sine. So meaning that in order for us to get the derivative where this sine came from, it was from cos. So meaning I'm going to use this second one. So meaning I'll come integrate. Now, okay, no, let me not even do like that. So what does it mean? It means that when you integrate what I have this side where this function I really want of sine 2x, when I integrate it, I'll be getting cos 2x. But what is very important for you to know, that here I only have a standing sine 2x. So meaning I will say this is negative 2 integral of sine 2x with respect to the x. Since you have only sine 2x, this is what you are interested in. Divide by negative 2, divide by negative 2, which will give you negative 1/2 cos of 2x is equal to the integral of sine 2x dx. Now, those who are not getting it, this is where we failed from. Integrating from that part. Similarly, that means now I want to summarize it again. I want to summarize it. Now, what does it mean? So when I have, let me say, I have cos 2x, and it is what I'm going to integrate. When we are differentiating, you notice that under differentiation, we multiply the digit. For integration, we divide. So what do? You get the angle you have here. First, differentiate it. When I differentiate 2x, I'll get 2. But since we are in integration, you will divide. Then ask yourself, when I integrate cos, what do I get? Whenever you integrate cos, you get sine. So it will be sine. Bring back the original angle as 2x. Then add on a constant of integration. May I know whether you have picked something small? First, I want to know, because that is where, once we don't know how to, then everything is going to be, yes, okay, somehow, okay, let me give more, take an example. I have an integral of maybe cos 8x dx. What am I going to do? I'll differentiate 8x. When I differentiate, I'll get 8. So I'll say 1 out of 8. When I integrate cos, what do I get? I get sine. But what was my original angle? It was 8x plus c. So in simple terms, maybe you can, whenever, but take note, I want you to take note. Here the cos must be to power 1. It shouldn't be cos squared d, sine squared d, cos power 4. No, it shouldn't have a power. So in simple terms, whenever I meet a cos of anything, let me say ax plus b, what I do, I'm going to differentiate this. So when I differentiate, I'll get 1. Okay, all right, no, I can write it. I think we can summarize it like this. We say 1 out of, will you be able to remember that this is the function? But let me hope. 1 out of the differentiate, or what you get here, which is a, then sine of ax plus b. That is when it comes to cos plus c. Similarly, when it comes to when you have maybe integral of sine of maybe ax plus b, what you do, for you differentiate this, you'll get 1 out of a, then the original thing, differentiate, integrate sine, you'll get your cos of ax plus b plus c. But remember, when you integrate sine, you get negative. So negative 1 out of a. I know you have not picked because the concepts are really many and we can't have all of them in the head one day. So, but we shall see what we can do by the end of at the end of the lesson. So that is where the problem came from. So here, I expected that we shall say our u is equal to x. Then our dv dx is equal to sine of 2x. Now, what are you going to do? You get your du dx. Our du dx is equal to 1. Our dv dx, like I've already told you, that when I have integral of sine of 2x dx, that I will differentiate this, I'll have 1 out of, I differentiate, then I divide. I come to the original thing is sine. I ask myself, when I integrate sine, what do I get? I get negative cos. I write the original angle. So meaning that my v will be negative a half cos of 2x. Then I feed into the formula. So I'll say my integral of x sine of 2x dx will equal to uv minus the integral of v du dx, then times dx. So come ask yourself, what is your u? Your u is x. What is our v? Our v is negative, allow me to put the negative here, 1 out of 2 cos of 2x minus the integral of my v, which is negative 1 out of 2 cos of 2x. Then our du dx is 1, then I'll have dx. Then I want to write this properly as negative 1 out of 2 x cos of 2x. Then this is negative. So allow me to have negative, that first negative. Inside there is a negative a half integral of cos of 2x dx. So here I'll end up with negative a half x cos of 2x. Negative and negative, once they meet, they'll form for you positive, 1 out of 2. Now, you integrate cos of 2x. But like I've told you, an integral of cos of 2x dx will yield for us, I go to the angle I have, I differentiate it. When I differentiate 2x, I will get 2. So I will say it is 1 out of 2. Then I ask, when I integrate cos, I will always get a sine. I write my original angle as 2x. So here we shall have 1 out of 2 sine of 2x, then plus a constant of integration. Clearly, this will be negative a half x cos of 2x plus, when I enter the half, it will give me a quarter sine of 2x plus c. But always it is a good practice. Meeting a negative person early in the morning is worse. So you'd rather meet a positive person than a negative. So you can arrange them in a way that you start with a positive sine of 2x minus the half of cos of 2x, then plus c. And now that is your answer. Let me know through the chat whether we're on the same page or at... Okay. Yeah. We're together. Okay. Yeah. And now what we are going to do, allow me not to go beyond this point, but let me first answer the questions in case you have any question.
Teacher, about the last answer, you've forgotten the x on a half.
Oh, the x, yes, it is. Oh, yeah. Okay, thank you. Okay, thank you. Yes, Brighton.
Okay, thank you, sir, for your service. I was just, if you're ending here, I was just requesting to go some more numbers in order to practice to understand the concept better. Thank you.
Okay, let me get, what is that? Okay, let me I think they're here. Okay. Yes, Diana. Oh, I saw. Okay, Peterson.
I wanted to know, what if there is a power where the angle is?
Yeah. Now, that one, you have to introduce double angles, eh? Yeah, but that one, I think we shall deal with it at when we reach there. Yeah, but that scenario is very possible.
Okay,
So
sir.
now there you have to remember those double angle things.
All right.
Okay, so the numbers you can try out now. There is this part D, part B. Even these ones, I want you to try them out. You can just take a screenshot, but I'm going to share it in your group shortly after here. Okay. I think I'm going to stop sharing the screen. Yeah, so I think we are going to end here. But yes, even the answers will be shared. I'll share the answers and I will also share, no, first do, then we mark our source. I can share the answers. Or alternatively, I can, when I get time, maybe today or tomorrow, I can shoot a video explaining all the numbers. Yeah, that can be another alternative that I can have. Okay, yeah, yes, Tracy. Okay, I think Tracy, you are going to unmute. Let me first stop the recording and then I allow you people, those who have questions to